I'm Gio, and my Genius Hour project is about algae and algae as a biofuel. And I'll be looking into what is a biofuel and how can algae be used as a biofuel as the main question. My motivations were learning more about renewable energy, in which this case were biofuels, which are also forms of clean energy. And along with that, I was interested into looking into alternatives from fossil fuels. And when I learned a little bit about biofuels, I wanted to I wanted to look more into that and like what it was and like how it can be used as an alternative from fossil fuels and what like exactly makes it better. And then with climate change getting worse, I think it's important to look into sustainable fuel sources. And I was especially curious about how the chemistry like behind all this plays a role into creating these fuels, especially ones like algae-based biofuels I'll be looking into. What is a biofuel? So the definition that I put right here and what I'm going to talk about is biofuels are made from plant or animal materials instead of fossil fuels, but although it's not limited to that, it extracts oil from organic materials and foods and waste and things like that. And then common types include ethanol from corn and biodiesel from vegetable oils or animal fats, like I was saying. And then chemically, they are mostly hydrocarbons, just like fossil fuels, but they're made through biological and chemical processing of biomass. And then this picture right here is what a hydrocarbon is and like how it's made up. And then why algae? What makes it so special? So what I'm gonna be talking about is algae is rich in lipids, which are oils and like natural oils, which it has, and then these oils can be extracted and turned into biodiesel through a chemical process called purification. This reaction uses an alcohol like methanol, or it's mixed with also methanol, and a catalyst such as sodium hydroxide to convert algae oil into a biodiesel and glycerol. The simplified reaction looks like this right here. And then having a lot of carbon and hydrogen atoms and those carbon and carbon bonds and carbon to hydrogen bonds is what gives it the ability to be energy filled sources because it stores a lot of energy. And when it's broken down and used as a fuel, those bonds are what release that large amount of energy, which also allows us to use it as a fuel. And then how exactly is algae going to be used as a biofuel and how can we use it like that? And then algae are, like I said, rich in lipids, natural oils, which is what we extract to use. And these oils can be extracted and turned into biodiesel through a chemical process called transesterification, like I was saying in the last slide. And this reaction uses an alcohol like methanol and a catalyst as sodium hydroxide, which essentially, like I was saying, converts the algae oil into a biodiesel. And the simplified reaction is this. And this is kind of an example on the right um, of what it looks like when the oil is extracted. And then once the oil is extracted, it's mainly not used alone, but rather mixed with with our- um with already existing fuels or fossil fuels. So it's mostly used in a combination, and in this example, that bottle is jet fuel. And the environmental benefits. One of the biggest environmental benefits of algae is that it absorbs carbon dioxide during photosynthesis because in the end it's still a plant when it's growing and being made and in these process where they're cultivated in these farms. It helps reduce greenhouse gases as well, since it also is a plant, like I was saying. And it can also grow on land that can be used for farming and doesn't need fresh water. It can grow in saltwater, even wastewater. That means it doesn't compete with food crops like other biofuels might. So they don't take up as much room. They don't, and they're very efficient with the space that they have. They're not taking any room from the crops or any other room like that. And then by using for fuel, we reduce our dependence on fossil fuels and lower overall emissions. Plus, since algae can grow in wastewater, it actually helps clean water by absorbing nutrients and pollutants as it grows. So it kind of is doing a two-way job at once, cleaning and producing fuel. And then finishing and wrapping this up for the conclusion slash takeaway. To wrap up what I've learned and what I've been talking about in this chemistry project, it's essential to understand how algae can be turned into a usable energy and how that chemistry process is. And then from the chemical reaction used to make biodiesel to the role of photosynthesis, chemistry makes it all possible. And algae biofuels offer a lot of benefits. It's renewable, grows quickly, and doesn't compete with food crops. Most importantly, it has the future potential if used more and integrated more into our system to reduce greenhouse gases emissions and help fight climate change. Overall, this project showed me how chemistry connects to real world problems and how it can be part of creating a cleaner energy for the future. Thank you.